Vevor sent me this new mag drill for a project. I actually bought the predecessor's predecessor back when they were yellow, and I tested the one that came after that, the first orange one. And both of those drills have been awesome, so my expectations were pretty high going into this test. This one comes with 11 annular cutters ranging from 12 millimeters to 27 millimeters. Plus there's a Jacobs style chuck for standard twist drills, a coolant tank and plumbing that goes with it, a lanyard for safety in case the power goes out and you're using it up a ladder inverted, and the 3 Allen keys you need to make adjustments. The whole package is on sale now for just over 400 bucks. One of the things that makes this kit in particular such preposterously good value for the DIY landscape is that it includes these 11 annular cutters. Now, depending on your neck of the woods, you might also call these rotary broaches. Different name, same tool, does exactly the same job. It's the same thing. Okay, it's a precision high-speed steel hole saw, basically. And one of the reasons that these are so nice to use is that A, there are so many cutting faces, and B, when you use a twist drill, you have to reduce every bit of metal in the way into a chip and eject it up the flutes and get rid of it. So you have to expend a lot of energy from the machine to do all of that mayhem on all of that metal, whereas a rotary broach just cuts out a ring and it leaves a solid slug in the centre. And when you assemble it with this pin, essentially, once you've cut all the way through, the spring tension from inside the quill on the adapter just punches out the slug and then you're good to go again. So what you get with the kit is you get from 12 millimeters up to 27 in diameter, and they'll cut steel up to 30 millimeters thick. So that's pretty much everything you'd ever want to do in a home shed environment, certainly. And I just price these up, and if you buy individual ones, just the high-speed steel ones, not the ones with 5% cobalt in them, they're going to average about 35 bucks a throw. So that's north of 350 bucks for this set of 11 cutters, and essentially, therefore, you're buying the drilling machine for, I don't know, about 100 and something bucks, and other drilling machines like this, magnetic-based drilling machines, just cannot compete with the economics of this because you're set up, good to go, out of the blocks for less than 500 bucks with the cutters. That's just preposterous. And the only thing I would suggest about the cutters is keep them really well irrigated with water-soluble oil like cutting fluid, because heat is the enemy. And if you do that, you just keep them nice and irrigated on the way through. They're going to last you for hundreds of cuts. Now, I have had the predecessor of this kit with these rotary broaches, and I've done hundreds of holes with some of them. In fact, when you make things like fixture plates, which I've done a bit of, you tend to drill dozens and dozens of the same sized hole over and over and over. It's quite monotonous, but I have never worn one of these out. I've never overheated it. They've just got remarkable endurance as long as you've got a bit of mechanical sympathy. Most of us have also got twist drills, and from time to time, if you want to drill like a 4 millimeter hole, you don't get 4 millimeter annular cutter because that's just not going to work, so you want to use your twist drills. And it comes with the hardware that you need to do that. So what you're looking at on this hand is an arbor that is, I'm going to say, Jacobs Taper 2 or something, but it's got the weld and shank on it. So it adapts this sort of Jacobs style of chuck to the weld and shank, and then you just insert it exactly the same way you would with your annular cutter. Now, tapers can be very scary from time to time, I suppose, if you've never done this sort of thing before, but really they just have to be clean. So that is step number one. You get a little bit of clean rag and make sure that you get rid of residual oil and grit and whatever else. And it doesn't have to be clean room clean. It's just got to be cleaner than the rest of the fat cave. And then you do the same thing with the male bit of the arbor. You just give it a wipe down to make sure it's nice and clean. And then assembly is like too easy because round peg goes into round hole, soft-faced hammer, it's not coming out. And the physics of that to me is just beautiful. Jacob's tapers, Morse tapers, all of that kind of work holding. Whoever thought of that is a flat out genius, and that's good to go. It's essentially never coming apart, or if it does, you'll have to work hard on it to make that happen. So that's genius. So that's pretty easy, okay? But there's a kind of obvious problem, isn't there? Because look at how much clearance we've got for a twist drill. That's not going to work really well if you've got one of these, which statistically everyone has, which is like a drill index of traditional jobber length twist drills. Actually, this one is really good. This is a great find as well. On special, these are well under $100. I'm going to say about 60. And they're really high quality. The Renegade Industrial is imported by a business in Queensland, and they're called Trade Tools, tradetools.com. Just search for twist drill, you'll find it. They also do a cobalt one with 5% cobalt that are really tough and durable. One of the cool things that separates these from other drills is the point. It's 135 degrees, and it's a kind of advanced split point grind. So the actual cutting edges have got 2 facets each, and they don't wander as much because they don't have a traditional chisel point. That's ground away to more of a straight point. So it's not as necessary to do a pilot hole, and they don't wander when you get started. So that's lovely. Anyway, I'm not affiliated with Trade Tools, but I've got a few of these indexes, and they are red hot value as well. The problem is obviously that this is the biggest one in the set. It's 13 millimeters, which is a decent clearance hole for M12, so you probably want to use that a fair bit. And I've got the quill as far up as it goes on the rack, and obviously there is not enough room to fit that drill, so that's a bit of a bastard, isn't it? And having watched quite a few reviews on YouTube, I see dudes do all this stuff. They go and weld together platforms that bolt or weld to the bench, and they're elevated to get you the clearance to fit the drill, to drill the holes. It's dogs and cats living together, and they haven't seen something that's hidden in plain sight, which I will show you now. See that? This is an adjustment for the height of the head. There's 2 dovetails here. There's one to drive the machine up and down in relation to this rack here. This pinion here is driving it up and down on the rack, but the head of the machine is adjustable as well for precisely this kind of problem, so that you can just solve it. And I'll just try and fly blind and fix it up here, shall I? So the head comes loose, and you can reposition it up to a maximum of that. There are stops at each end, but here's the maximum height of the head. You just tighten this pin back up, sets the head up wherever you want on the dovetail, and then if you want to use a nice long drill, Bob's your mother's brother, okay? There's your 13 millimeter drill in the chuck, ready to rip, and we haven't had to do anything heroic. The tool comes configured. It's well thought out, so that if you want to drill a hole in, I don't know, some piece of scrap, stand by. You put this somewhere where you can clamp it to the table so it can be safe, and obviously the drill turns clockwise as you look at it, so it might be a lovely idea to brace that edge of it against the body of the drill itself so it can't start to helicopter. And then you just drill. Obviously the magnet's not turned on at the moment, so it's not stuck to the table, but there's your solution for every twist drill in the box. All you have to remember is the head uppy downy screw. I guess one key question is, do you buy this or a drill press? Not that they're mutually exclusive, there's no law against owning both, but if it's one or the other, the correct answer kind of depends on the work that you plan on doing. Mag drills, of course, really excel in situations where you can't take the job over to the drill press, or if you could, it would just be too big and too heavy to hold it in place and drill the actual holes. I'm not going to pick up and move this 300 kilo fabrication bench to a drill press anytime soon, but drilling these 10, 15 millimetre diameter clearance holes into the bench top, which is 8 millimetres thick, is child's play for this mag drill. 15 millimeters is a clearance hole for the M12 by 1.75 set screws that I'm going to be using for this setup. It's roughly the same size as the hole in the high tensile washers. I've got 6 or maybe 7, can't remember, mag drills, right? And don't judge me, dude, it's a sickness, okay? Anyway, they all come with something like this, which is gravity-fed coolant irrigation type reservoir. There's a couple of set screws on the side, you screw it in, it comes with a little piece of PVC tube, you hook it up, and Bob's your mother's brother, you're lubricating the tool. Unfortunately though, I hate it. So in practice, what I do is I get this and I put it on a shelf and I never go near it again, and I reach instead for my trusty little squirty bottle of coolant, which is water-soluble cutting fluid, right? Now, a couple of things about that. This stuff is dirt cheap. You buy it in 5-litre bottles, and I think it dilutes it like 20 to 1, so that's enough for 100 litres of this stuff, which is 200 of these bottles. And this is just a universal solution for me on a mag drill anywhere, or anywhere in the fat cave where I do cutting, like on the bigger bandsaw, I use that to keep the blade cool, and on the drill presses here as well. And in the other shop, I use it on the milling machine, and I use it on the lathe, and I use it on the other drill presses, and occasionally on the bandsaw, blah, blah, blah. Even though I have coolant pumps for some of those tools, this stuff is not that precious, it's dirt cheap. And being water-based, it's much more effective at keeping the tool cool than some pure oil type lubrication. You have to understand the distinction between lubrication and coolant. Coolant is much more important in this kind of environment. And yeah, there is some lubricity with this, but it's mainly water. And water has this miraculous ability to absorb heat. And heat is the enemy when you're moving metal quickly. So don't spare the irrigation. There's absolutely no secret to why when you go in a mass production environment and you see all those CNC machines in big cabinets cranking out parts as quickly as possible, the cabinets are all shut, and it's a typhoon of this stuff in there. And that's because heat is the enemy, and more lubrication allows those machines to run flat out, make more parts per unit time, because time is money. And I'd suggest that if you use one of these things on any project, don't spare the coolant. Annular cutters are beautiful to use if you've never used them. It's a completely different drilling experience. They cut smoothly and efficiently, and the internal finish on the holes is outstanding. What I'm building here is a big fixturing square that sits on the bench. It's actually bolted to the bench. It's like a jig for welding. Those clearance holes that you just saw are for matching M12 set screws to pass through. So I thought I'd switch the mag drill to drill chuck mode and see how it performs drilling the blind holes in the fences of this fixture. They're 10.2 millimeter diameter holes, which is the tapping size for M12 by 1.75. One of the cool upgrades they've done with this machine compared with its predecessor, I'm pretty sure, is they've interlocked the magnet with the drive for the spindle. And what that means in practice is that at the moment, magnet off, power on, you accidentally hit start the drill and it doesn't spin. And that's a pretty good safety feature when you think about it, right? But when you apply the magnet, and this thing is super strong too, you're not moving it anytime soon, you apply the magnet, you're active again, okay? So you're off to the races, but you can't accidentally start the spindle with the magnet off. See, magnet off, drill on, she's not working. If you do that as a tester, just remember to hit off. Otherwise, if you energize the magnet, it's going to start spinning. Okay, but you can test that when you pick it up. Just remember to turn it off before you re-energize the magnet. The average drill press, of course, comes with a depth stop, and mag drills don't. So I quickly had to put together a Ghetto depth stop to do this, based on an equally Ghetto machinist jack, which is really just a couple of nut, a set screw, and a nut, all M12. I just stick that under the rack to limit the downward travel, and then I put a 12mm shim under the drill, and I loosen off the head height adjustment and reposition it so the drill cannot get closer than 12mm to the surface of the bench. This is an offcut of that 32mm bar that I drilled the blind holes in, and obviously I did a test first. It's always a really good idea to do that so that you don't scrap a part that you've got, you know, time and money invested in. So the Ghetto depth stop worked really well. It sat there for all of those holes, didn't move around, and I got really good consistency. I measured that with my trusty verniers. This is the easiest way to measure blind hole depth, is with the measurement probe on the end of your verniers. You just sit the calipers in there, hold the top bit down, push the probe in, measure it up. She's 20mm, good to go. Keep measuring as you do it, just to make sure that there's not some incremental change over time if you're doing a lot of it. And the beauty of having a blind hole, although it is a bastard to tap, is not just aesthetically. When you invert it and you screw it down to the table, when you work in an environment like this, there's all sharp metal chips getting ejected from drilling and cutting and grinding, and there's dust and welding slag and things of that nature, and you don't have any unnecessary recesses like little holes where the fastener is not all the way up and flush. You don't have that, right? So it's easier to clean up, and you're not going to cut yourself as easily and things of that nature. So it's just a much needed job if you can do that. And being able to Ghetto engineer a depth stop in a drill press like this, a mag drill type press, is a real advantage if you want to elevate your Ghetto fabrication game. So I just drill that out 10 times and then deburr it all with a countersink, and I'm good to break off a tap in the very last hole and scrap the whole part, as frickin' usual. Or perhaps there will be a miracle this time. There's always hope. Other companies, and I urge you to go online and have a look around. In Australia, at least, they're unafraid to sell a drill like this with similar performance specifications on paper for upwards of $1,000, and you have to buy the cutters separately, and they're about $35 a throw. So that's a different landscape, isn't it? If you're a steel fabricator and you do this for a living, you need a mag drill, you're going to flog it. Like every week it's going to get flogged. Then buy one for $2.5 grand. It's going to be more powerful. It's going to have a number 3 Morse taper shank. You can hold more stuff in it. You'll probably be able to drill a 75mm hole in a 2-inch thick piece of steel, but I can't remember the last time I needed to do that. And frankly, for the amount of work that I give a mag drill, which is probably more than your average home gamer, $400 is just a lot easier to swallow. And I know import tools can be a bit of a hit or miss proposition, but I've played with 3 of these now, and this thing is a hit. It's a really good tool and astonishingly good value given what you get for the cash. This Vevor mag drill and the 2 predecessors which I still own and which are still going strong have functioned flawlessly for me. The magnet is really strong too. It's like parking a Yaris on top of the machine just to hold it down, although it's a lot easier just to flick the switch on the magnet. So it's more than enough if you're on thick-ish steel plate. 12.5 kilonewtons is the official rating, which is about 1.3 tons of clamping force. I urge you to remember that if you're ever in a position where you're drilling horizontally into something or vertically up into something, and the magnet on this thing is easily strong enough to support the drill's own weight in those orientations, there's no problem with that. But if you are in those situations, let's say you have to drill 4 holes horizontally up some ladder in the flange of a column, or even harder, inverted on a piece of scaffolding into a piece of plate vertically up, then I urge you to organise some sort of robust tie-down strap lanyard situation for this, because all it takes is a power failure. That just means some bozo over there to trip the breaker by doing something stupid, by earthing something that really wasn't meant to be earthed, or in a domestic environment, the kids could play and just kick the extension cord, whatever, and all of a sudden the magnet doesn't work anymore. You've got a nearly 13 kilogram projectile potentially over somebody else's head. And the consequences of that are unthinkable. So get a ratchet strap. I know this thing comes with a lanyard and it's okay, but it seems a little on the flimsy side to me. I'd get a reasonable heavy duty strap if I was going to use it in that situation, and I would make sure I would practice a power failure. I'd go magnet on, magnet off, and just see if the strap is going to catch it before you go doing any Cirque du Soleil crap with a product like this. Officially, the motor is rated at 1450 watts, which is plenty of drilling grunt in practice. And I just measured the travel pretty roughly. The quill travels about 130 millimeters, and there's another 90 millimeters of height adjustment of the head via the opposing dovetail. And all up, the whole unit weighs about 13 kilos, just under, I think. Anyway, it's easy enough to carry from the ute to the job. If you've never used one before, a mag drill is fun. It's also a super efficient way to get big holes in thick steel, and it's a versatile tool as well because you can use it in all of these orientations. If you're thinking about mag drill versus drill press, then obviously part of that equation depends on what you're going to do with the tool, but another part of it depends on your shed and how it's set up and what the constraints are. Because if real estate is your principal constraint, then I'd suggest that something like this is much easier to fit into the shed, isn't it? It can go away even horizontally in a shelf when you're not using it, freeing up your bench space, whereas a drill press really has to be there the whole time, kind of thing. Not much good for wood, a bit slow for wood. I'd suggest that this being one speed only is a salient difference between it and a drill press. I did think it was about 700 RPM just based on how it felt to use, but reading the back just now, it's 850, which is fine for the majority of drilling in steel. Technically, it's a bit slow for the smaller bits and a bit fast for the bigger bits. It's okay for the annular cutters though. They're super efficient at that kind of speed. So I would say, irrespective of what you're drilling, irrigate a lot because heat's the enemy. This is quite quick for some of those larger drills. And if you want your expensive high-speed steel tooling to last as long as possible, just irrigate a lot, but keep it cool because that's what they do in heavy industry when they're in a mass production environment. There's no reason you can't do that in the shed at home. Another limitation with a mag drill is the throat depth, which is basically the distance between the front edge of the body of the drill and the center line of the drill. The main application of this tool is to be used on top of a piece of plate, obviously, so you can put the hole wherever you want. And they've made it nice and rigid by minimizing the throat depth. But if you want to stick it to your bench and feed stock into it, then you need to be able to accommodate or work around the limitation of the throat depth. It's okay to feed stock into it this way, that's dead easy. So anything up to about 60 millimeters wide, you'll be able to drill down the center of that no problem by feeding it in this sort of transverse direction. But anything bigger than that, you'd have to basically stick the drill to it and then drill it like the thing that you're drilling is the base, kind of thing. Not that hard to work around the throat depth, but it is something to consider. And the final thing is, what are you going to stick it to? Obviously you need a steel top, but if you're drilling into thinner stuff like 2 millimeters thick or something like that, sheet metal, whatever, the thing about magnetic adhesion is this is 8 millimeters thick. It's quite solid. You're not going to break it free easily. You probably could by levering on it hard, but you can't accidentally get it off, and by drilling into whatever, you're not going to lift it off. This is not the case on a really thin piece of plate because the magnetic adhesion force is related to the thickness of the steel that you're sticking it to. The thin stuff does not get gripped as hard. So you're not just going to put a bit of sheet metal on a wooden bench and stick a mag drill on it with the full 1.3 tons of downward force, is what I'm saying. So anyway, that's how I see the ownership economics and usage case stacking up. As for value, if this thing lasts only half as long as, I don't know, $1,500 mag drill and $500 worth of cutters that you have to buy separately, then you are still massively in front, dude. And Anyway, the price point is so much lower than so much of the competition that it just opens the door to mag drill usage and ownership so much more broadly into the Ghetto engineering community that I thought it was probably worth talking about it with you here today. So anyway, thanks for joining me on this one. I'll do a separate video that just talks about the fixture square and how I went with that and what I can use it for, because if you're thinking about getting into fabricating, that might be something you're interested in as well. And if you're interested in this drill, it's on sale at the moment. The value's outstanding. Link in the description.